Good morning. Did you know that the first car built by Henry Ford in 1896 had no reverse gear? Good luck parking that car. Reversibility is a necessary characteristic of a good system. In this lesson, we will continue discussing those mathematical operations that reverse the effect of the other. Factoring the difference of two squares is the reverse operation of finding the product of the sum and difference of two numbers. Let's begin our lesson. Learning begins with a question. Here are the three questions that we are trying to answer in this lesson. Number one, what is a difference of two squares? Number two, how do we visualize the difference of two squares? And number three, how do we factor the difference of two squares? So you can understand it better, let's do some paper cutting activity. So let's visualize the difference of two squares. What I have here are two squares. Let's say that the length of this square is A. So from here going to that part, the length is A. Since this is a square, it's implied that this is also A, this is also A, this is also A. Now let's also suppose that this smaller square has a length of B. So what's the area of this square? It's A squared. What's the area of this square? That's B squared. If I am going to subtract these two, if I subtract the two, the big square minus this smaller square, that is geometrically equivalent to cutting away this part. So the big square minus the smaller square, A squared minus B squared would be equivalent to cutting away that part. So let's cut that. So this resulting square is now A squared, and we cut the B squared. So that becomes A squared minus B squared. But what is now the factor of this shape? Notice that we said we can factor the shape if it is a rectangle because we can just get the length and the width. But this is not a rectangle. So what we are going to do is we continue cutting this so that we can form a rectangle. So we can cut it here. But before we cut, let's label the parts. If this is B units, then we know that this length here is also B. That is B. Now, if originally this length is from here going here is A, if we subtract this part, then from here going that way would be A minus B. The reason is originally the entire length is A, but we remove this B, so it becomes A minus B. Equivalently also, from here going to that part is A minus B because from here to that part is B. Now let's cut along this line. So from the original A squared, we cut the B squared, so this area would be A squared minus B squared. So that would be the A squared minus the B squared. Now, I can remove this and put that here. And now, I have a rectangle. And the area of this rectangle is A squared minus B squared. So let's find now the length and the width. So we now have a length of A plus this, which is B, and a width of A minus B. So that is precisely what we have here. A plus B. A plus B is this. A minus B is this length. And the entire area is the big A squared subtracted by B squared, which is this A squared minus B squared. That is the reason why we have this formula, because if you are given the area like this, you can always cut it and rearrange so that you can find the length and the width, which are the factors. And if you are given the factors A plus B and A minus B, you can always rearrange it to visualize that this is just the big square A squared subtracted by this b squared, the smaller square. So that is the meaning of this formula. So, based on that demonstration, we can now say that in order to factor the difference of two squares, you will have the form, the first term, a squared, minus the second term squared is equal to the sum and difference of the two terms. So, a plus b is the sum times a minus b is the difference. This is now the formula that we are going to use in order to factor difference of two squares. But in order to do that, you must be able to recognize that the expression that you are factoring has this form, a squared minus b squared. So let me give some examples. Factor x squared minus 1. So we said the form should be a squared minus b squared. We can see a form like x squared similar to a squared, but we don't see the second one. So what we need to do is rewrite this as x squared minus 1 squared. Why can we do that? Because the square of 1 is still 1. 1 times 1 is 1. So these two are equivalent, but in terms of the form, this one has no square, this one has a square, and this one fits perfectly to the a squared minus b squared form. So that's what we want. And now that we have this a squared minus b squared form, our a would be the x, and our b would be the 1. So our a is x, plus our b is 1, and then a minus b. X is our a. This time you have the minus, and then our b is 1. So x plus 1 times x minus 1 would now be the area of this unshaded region. This x plus 1, you can think of that as the length and x minus 1 as the width if you are going to cut this portion and then put that and then transfer that here. So if this area is transferred here, then we'll have x plus 1 as the length, and this width would be x minus 1. Okay, let's have another example. How do we factor 9x squared minus 1? So it's the same technique. We need to rewrite this so that it looks like a squared minus b squared. So we can write this as 3x squared minus 1 squared. Now this is very important because you cannot just look at this as x squared and not considering the 9. This must be the entire term raised to the second power. So it must be the entire 3x that is raised to the second power and the entire second term raised to the second power. How do we do this? Why is this equivalent to that? Because 3 squared is 9, so 3 times 3 is 9, and x squared is of course x squared, and 1 squared. So we now have the form, the first term raised to the second power minus the second term raised to the second power, and the factors of this are the first term 3x plus the second term, and then for the second factor you have the first term again 3x, but this time it's the minus 1, the sum and difference of two numbers. So this is now the factored form of 9x squared minus 1. Now, what if you have this problem, 150k squared minus 216? In this kind of problem, we are going to use what we learned in the previous chapter, which is factoring out first the common monomial factor, or factoring out the greatest common factor. The greatest common factor of 150 and 216 would be computed this way. Now, to get the prime factorization of 150, we just make a factor 3. This is 2 times 75, and this is 5 times 15, and this is 3 times 5. So the prime factorization of 150 is equal to 5 squared times 2 times 3. Now, for 216, this is 2 times 108. This is 2 times 54, and 54 is 2 times 27, So for the prime factorization, so 2 times 3 equals 6. 6 is our greatest common factor. So we get that 6 as our GCF. We factor out the common factor. And then we divide. 150 divided by 6 would be equal to 25. Then copy the k squared. 216 divided by 6 is 36. You can just check my computation. And then this one is still not in the form a squared minus b squared. So we need to do something so that this form will look like that one. What we can do is, notice that 25 can be written as 5 squared and then k to the second power. So you can verify 5 squared is 25, k squared is k squared. That's correct. Then 36 can be written as 6 times 6 or 6 squared. So this is now our first term, 5k. That's our a squared. And 6 would be our b. And this becomes b squared. We know how to factor this by following this formula. So we now have 6 so that I do not forget, I usually write the placeholder already because I know that if I have the difference of two squares, I have a plus b, a minus b here. So, this is plus here, this is minus. And then what's the first term? 5k. And then the second term is 6. The first term here is 5k. The second term is 6. So, the complete factorization now of 150k squared minus 216 is 6 times the quantity 5k plus 6 times the quantity 5k minus 6. Or we can write this as 6 times 5k plus 6 times 5k minus 6.